So in this question, use rectangles to estimate the area underneath the curve y equals x squared between x equals 0 and x equals 4 with an interval of 1. All the interval of 1 means is that the x values go up by 1. So 0, 1, 2, 3, 4. So basically between 0 and 4. And when you draw the rectangles, they would have a width of 1, which is the interval. So to work out the area beneath the curve, and you can see that the area of these rectangles, because you've got this little triangular bit above the curve, they're going to work out to be more than the area actually beneath the curve between x is 0 and 4. So these ones will overestimate the area. And the way to work out the area of those rectangles is just to use the length times width formula for each one. And so you know the width already, that's going to be 1, and the height you have to figure out. And the way you do that is because this point up here, which is the top right corner of this rectangle, the tallest one, has an x coordinate of 4. To figure out the y coordinate, you just sub it into here and get 4 squared, which is 16. So that means the y value at that point is 16, and thus that's the height of that rectangle. So the y value always gives the height of a point above the x-axis. So just by finding the y values of each of those 4 points where the rectangles touch the curve will give you the heights of those rectangles. So with this one, the x-coordinate at the top of that rectangle at that point is 3. Subbing 3 in to y equals x squared, you get 3 squared, which is 9. And then here when x is 2, 2 squared is 4, and then when x is 1, you get 1 squared, which is 1. And so all of those heights are going to be times by 1, so you get those same numbers for the actual area of each rectangle. So the height of this one was 9. 9 times 1 is 9. This one was 2 squared, which is 4 for the y coordinate. So the height was 4. 4 times 1 is 4. And the last one, 1 times 1. And then you just add up those 4 numbers and you get 30 for the total area of those rectangles, which is an estimate for the area under the curve between 0 or x is 0 and x is 4. So that's one way of doing your working. When you get more complicated equations like e to the x or a more complicated quadratic equation, another way of setting it out is to use a table like this. So you put the x values in here, and only the x values that correspond to points or corners on the rectangles that actually touch the curve. And there's 1, 2, 3, 4 of those, and they each have the x coordinate of 1, 2, 3, 4. So that's what you put in the table. Then in this column, you figure out the y values by subbing each of those x values in, which is pretty much what I did up here. And then you add up those values to get a total of 30, and then using the area is the length times the width. And if you were to stack these rectangles on top of each other, so you had a single rectangle that was 1 unit wide, it would work out to be 30 units high. And so this number here is always telling you the total height of that rectangle. And whatever the width is, if it's an interval of 0.5, you would times it by 0.5, but the width in this case happens to be 1. So that total height of 30 times by the 1 equals 30, the same answer I got adding the 4 numbers up before. So this is just a more compact way of doing it rather than setting out working across the page, and it's the way that I show my students, and it's quite an easy way of doing it. So that's that first example. This one over here is where the left-hand top corner of the rectangles touch the curve, and this, as you can see, is going to underestimate the area beneath the curve because you're leaving out these little triangular bits here. And there's only 3 x values for this particular example. The 3 left-hand top corners of those rectangles touch the curve, or there's only 3 points from those rectangles that touch the curve. So there's only going to be 3 x values, and they are 1, 2, and 3. And again, if you were just doing this and you hadn't seen this, you would have to work out the height of each rectangle by subbing the x value into the equation, which I've done here to show, well, to show you. And there you are, Sunday morning. And so, yeah, so the x coordinate here was 1, 1 squared is 1, the x coordinate here is 2, so the y value would be 2 squared, which is 4, so the height there is 4, and just doing the same thing that I did over here. So this time you only get the numbers 1, 4, and 9 when you sub in these values into y equals x squared, and they total 14. So again, if you stacked those three rectangles on top of each other, they would have a height of 14 altogether and a width of 1, and length times width would give you 14 times 1, which is 14, which is way less than, well, it's less than half the estimate that you get doing it this way. So definitely a big difference between the underestimate and the overestimate, or the left-hand endpoint method and the right-hand endpoint method. I think that's what it's called. What's important is that when you're given a question like this, if you're just given a worded question like this, the important thing is that you know how to set up the diagram and then figure out the areas of those rectangles. That's really what you've got to do. And key things about what numbers to put in this table if you're going to use a table to set your work out, which I recommend. It's an easy way of doing it, especially when, as I mentioned before, the equations are a little bit harder and require the use of a calculator to figure out these y values. So, and so that's about it for this lesson. If you have any questions, please ask them, and I'll see you in the next one.